the question is, in the rolling friction, so the body is rolling on the surface of the road. The tire is rolling on the surface of the road. Now, this is the direction. So, the frictional force, should it be A or should it be B? That is the question.
B.
The frictional direction of the frictional force, should it be A or should it be B?
B.
B. Yeah, it is B. Okay, the frictional force is like this. Okay, this is the frictional force Fr. Fr is the frictional force. Okay, so we can write here friction between rolling body and the surface. Friction between rolling body and the surface. Rolling body and the surface. That is rolling friction. Now, next one, we have inertia. What is inertia? Second concept is inertia. What is inertia? Anyone? What is inertia? Inability of the body to remain in the same state of rest, comma, motion or direction. Okay. Here, inability of the body to remain in the same state of rest, motion or direction is known as inertia. Okay, is known as inertia. Now, there are types of inertia. What are the types of inertia? Types of inertia. There are three types. Inertia of, first one is what? Inertia at rest. Inertia at rest. Second one, inertia of motion. Third one is inertia of direction. Inertia at rest, inertia of motion, inertia of direction. Inertia of rest means what? Like suppose the body is at rest. Like you're sitting in the bus, the body is at rest. And the bus started moving. So what happens for a moment, you will go back, is it not? You just go back and then come back. Even though bus has started, you are still in the state of rest. Even though the bus has started, still you are in the same state of rest. That is said to be inertia at rest. Inertia of motion means what? Example, like suppose, one more example I can give, inertia of rest. Like suppose there is a carpet or a bed sheet, something like that, or something, or a blanket. So you hang it, take a stick and hit it. So what will happen when you hit, what happens? The bed sheet, the carpet will move away from its place and the dust will dislodge, or the dust will fall down. Because the dust was at rest, so the dust will come down. So that is the inertia of rest. Inertia of motion. Example, you're standing in the bus and the bus is moving and the driver applies the brake. What will happen? Your feet will come to rest. You will fall in front, right? The reason is your feet will come to rest, but the body doesn't come to rest. Feet comes to rest, but the body doesn't come to rest. That is inertia of motion. Inertia of direction. Inertia of direction means, like suppose you're sitting in the car and the car is going fast, and the driver takes right turn. When he takes right turn, you'll be thrown on the left hand side. Is it not? When you once again, you are going in the car and the driver takes right turn. When he takes a right turn, you'll be thrown at the left hand side. Is it not? Yeah. So this is about inertia of direction. Means still, even though the driver has taken a right turn, still you are in the same direction. So that is the reason you are thrown on the left hand side. Is it clear? Is it clear, all of you?
Yes, sir.
Yeah. So these are the three different types of friction. So this is about the first law of motion. And once again, the first law of motion, it says that the body remains to be in the state of rest or in the state of motion, unless and until it is compelled by an external periodic force or external force. Means if you keep the body here, it will be there for millions of years unless and until someone stops it. Someone moves it. Or if you throw a ball in the space, it keeps on going unless and until someone stops it or someone changes the direction of the ball. So that is the first law of motion. In the first law of motion give rise to two concepts. One is friction, second is inertia. So in friction, we have four types of friction. First of all, friction means what? Opposition to the motion of the body is said to be friction. So there are four types of friction. What are they? Static friction, limiting friction, kinetic friction, and rolling friction. Static friction means you are applying the force on the body and the body doesn't move. Means my applied force is less than the frictional force. My applied force is less than the frictional force. And the body doesn't accelerate. The acceleration of the body is zero. That is said to be what? That is said to be static friction. In limiting friction, if applied force and the frictional force both are equal, then that is known as static limiting friction. The other name of limiting friction is maximum static friction. Okay. So where both are equal and still the acceleration of the body is zero. Third one is what? Third one is kinetic friction or dynamic friction or sliding friction. Three names for this. So in the why I have given three names? Because in the numerical, instead of saying kinetic friction, he will say sliding friction. The body is sliding. So you should be aware that sliding means we have to apply their kinetic friction. People what they think sliding means it is rolling. They understand in that way, and they apply rolling friction formula. Is that clear? So should be little careful with that. Fourth one. So in the third one, applied force is greater than the frictional force. The body starts moving. So applied force minus frictional force equal to the resultant force. F minus F is equal to capital F minus small f equal to MA. MA is the resultant force. Fourth one is the rolling friction. Rolling friction is the applied friction between the rolling body and the surface. So this is the direction of the force and this is the direction of the rolling friction. Next is the second concept, which was given by Newton's first law of motion, is inertia. Whole this the whole mechanics in mechanical engineering or whether you go to any engineering, any engineering in first year out of 4 years, the first one is common syllabus. Means first two semesters are common to every engineering, whether you take civil, mechanical, or EEE, or ECE, or computer science, any engineering. First year, 2 semesters will be there. That they are common core, common syllabus, or common subjects. It will be mathematics 2 papers, semester 1, semester 2, 2 mathematics papers, physics paper, chemistry paper, mechanics. Mechanics will be there. In mechanics only you will be using first law, Newton's first law. There also you will be using physics again. Complete physics, free body diagrams. Okay, you'll be using all these free body diagrams and all. Now, inertia.
Sir,
Yeah.
sir, in inertia, shouldn't it be ability of the body to remain in the same state? Oh,
Can you say it again, please?
sir, in inertia, how is it inability of the body to remain? Shouldn't it be ability of the body to remain in the same state?
I mean, inability means
So
the
because
body
it remains in the same state, right?
inability. I mean here. See, the body in the state of it has to be in the state of rest, but it's not in the state of rest. That's the meaning of that. Suppose static friction. When the bus started, still the body should be in the state of rest, but it's not. It didn't happen like that. Got it?
Okay.
In the motion also, when the body is moving, it should be in the motion, but it came the person fell down. Okay, still it should be supposed in the state of motion only, right? That didn't happen. That is the meaning. Got it?
Yes.
Okay. Now inertia, rest, motion, and direction. I have given an example for each. One is a bed sheet or the carpet. One is the person standing in the bus. One is the person thrown on the left hand side when the car is taken right direction. Understood? So these are the applications. Now next concept is momentum. Okay, momentum. What is momentum? Momentum is the product of mass and velocity. The product of mass and velocity is momentum. So we write here momentum equal to mass into velocity. So we write P equal to mv. Units of momentum is what? Kg meter per second or Newton second, and it is a vector quantity. Clear? It is a vector quantity. The product of mass and velocity is said to be momentum. Momentum is mass into velocity, and it is a vector quantity measured in kg meter per second. So here we have the body here, m is the mass of the body, V is the velocity of the body. Okay, so momentum is what? Mass into velocity. Is it clear? Please note on this quickly. We will go to the next concept. That is second law of motion. Then impulse is there. Then conservation of moment. So the rate of change of momentum is directly proportional to the applied force. Directly proportional to the applied force, and accelerates in the direction of the resultant force. Accelerates in the direction of the resultant force. Okay. The rate of change of momentum is directly proportional to applied force and accelerates in the direction of the resultant force. That is Newton's second law of motion. Now suppose we will derive F is equal to ma. Okay. Derive F equal to ma. So suppose there is a body whose mass is m and whose initial velocity is u, whose final velocity is v, and the displacement is s in the time t. Body whose mass is m, initial velocity is u, final velocity is v, displacement is s, and time taken is capital T. So we have here initial momentum pi equal to mu, pf equal to mv. This is initial momentum. Okay. Initial momentum, and this is final momentum. Initial momentum and final momentum. So we have change in momentum. Change in momentum. That is what delta P equal to Pf minus Pi. Change in momentum, Pf minus Pi. So we write here delta P is equal to Mv minus Mu. So delta P equal to M into V minus U. Now we have rate of change of momentum. Rate of change of momentum. So that is what delta P by delta T. How much time? How much change in momentum? So we write here M into V minus U by T or delta T, whatever it is. You can write delta T, no problem. So that can be written as M into A. So this is equation number 1. But from statement or from the law, what is that? F is directly proportional to delta P by delta T. That is equation number 2. So we have from 1 and 2. From 1 and 2 we have F is proportional to Ma. So F is equal to what? Kma. Okay, if K equal to 1, F is equal to Ma. So that is the equation, that is the law. Clear? Once again, a body whose mass is m, initial velocity is u, final velocity is v, displacement is s in time t. Now, initial momentum is what? Mu, final momentum is mv, change in momentum is pf minus pi, that is final minus initial momentum, that is delta v, that is mv minus mu, take m common, v minus u. Rate of change of momentum, in how much time, how much change in momentum, then we get ma. So from the second law, F is proportional to delta v by delta t. From 1 and 2, we get F is equal to proportional to ma or kma. So if k is equal to 1, F is equal to ma. Clear? Is it clear? Yes. Okay. Please do copy this first, then we'll go to the impulse. Now we'll go with the impulse. Okay. So how do you define impulse?
Force into time.
Yeah, can you be a little louder?
Force into time. So I don't know how to define.
Force into time. Yeah. So impulse, we say I. In some books it is I, or some books it is delta P also. So we can say effect of force for a short duration of time. Effect of force for a short duration of time. That is said to be impulse. Effect of force for a short duration of time is impulse. So we write I is equal to F, or we have one more definition, change in momentum. Change in momentum. Change in momentum. That is said to be impulse. So we have two formulas here. I is equal to F into delta T. Or we can also write I is equal to mv minus mv. Okay, mv minus mv. So what is a unit? Unit is what? Kg meter per second or Newton second. So there are examples. Let us discuss few examples. Number one, fielder taking a catch. In cricket, fielder taking a catch. So what he does? Suppose a fielder is taking a catch. What does he do? So when he takes a catch, he pulls his hands backward. Is it not? Did you notice this? When a fielder is taking a catch, he holds and he brings it back. Why? Any idea? Anyone? When the fielder takes a catch, he pulls his hand backward. Why? What is the reason behind it? He can keep just like that, right? Yes? Anyone?
Because it comes with a force.
Yeah. Can you say it a little louder?
Sir, it comes with a force.
See, it's like he's reducing the force on his hand by pulling it backward. He's giving some time to his hands and to reduce the force on his hand. Understood? So yeah, giving the ball more time. That is also we can say, but to reduce the force on his hand. That is one example. Second example, when especially the crockery or glass items or electronics, when we carry from one place to another place, between the plates you might have seen, they keep some cartoon pieces or paper fillings or thermocol. You might have noticed this thing. Is it not? Between the crockery,
Yes.
like the plates, glass plates, there is like cartoon pieces, papers, or paper fillings, or thermocol is placed between the two plates, okay, or electronics. We use this. Why? Because when you are taking the crockery or electronics from one place to another place, due to vibration or due to the impact, when suppose if there nothing is there, one will hit each other and they will break. Okay, so we are giving, by doing this, by placing that, we are getting enough time so that the impact is taken by the, we are giving some time for that. The more the time, less will be the impact on the object. Clear? So I'll write here. The second example is what? Crockery. Crockery or what is the example? I say electronics, electronic items. Electronic items. We use paper fillings or paper fillings or thermocol or cartons. Carton. Okay, we use this. One more example. You know the high jump? High jump. Like a person will go with a long stick. Okay, the person goes with a long stick and he jumps from there, right? He keeps the stick and he jumps on the the ribbon or something else. Have you seen that? So there is a cushion at the down at the bottom. Did you notice this? Did you watch this anytime?
Yes.
You can think that. So what is happening when the person jumps like this? What happens? There is a cushion. So if he'll go down and come up, is it not? The person goes down and comes up. So the more the time, the less will be the impact on the person. Suppose I go and hit on the wall now. Will the ball go inside? Does the ball go inside? It doesn't go, right? Yeah. So when I hit on the wall, so my hand will pain. Why? Because the whole force is absorbed by my hand. But in the case of high jump, there is a cushion. The cushion is the more the cushion will go down and it will come up. More the time, less will be the impact on the person. Think that there is no cushion at all. What will happen? The person jumps and there is nothing at the bottom. What will happen?
The spine will break.
Yeah, final destination, right? FD. Have you seen FD5? You need to watch that. Okay, final destination. So person will reach FD. Okay, there is no other way. So means the whole force is absorbed by the person only. That's the reason. So that is why two more examples I will give. That is why when we sleep, nowadays we have memory foam, right? Memory foam on which we sleep, the carpet, the mattress. There are very good mattresses nowadays, and we have pillows also, memory foam. So if you sleep, you will have the complete sleep, that is without any disturbance, right? So why it is happening? Because the impact of our body, there is less impact on the body, so automatically you sleep well. And on the Majas or side, or on the if you go to Al Hira beach, there is a jogging track, or Jumeirah, you can see there is a jogging track, right? Did you notice that?
Yes.
Yeah, jogging track. There is a cycling track, there is a jogging track. The jogging, did you anytime run on the jogging track or walk on the jogging track?
Yes, sir.
What do you feel there?
Sir, is it the
So it's not
synthetic
hard
track?
like a normal, like the road surface is not hard.
It's not hard. Okay. Any other observation? Any other observation? Yes, someone was saying. When you're walking on the jogging track, what did you observe? It's not hard. One more. No one has observed. No one walked on the jogging track anytime.
Yes, 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 yes.
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 See, jogging track is a little smoother than the normal road. Okay, so it's made up of rubber and some other material. So it is little soft. It protects your ankles and your knee. So that is why whenever you are walking, if you want to really jog or if you want to run, take the jogging track. So your knee and the ankle will be protected. For that reason, they have used it. Okay. So what happens? The impact on the knee and the impact on the ankle will be less, because that the cushion will go down little and come up, go down, come up, go down, come up. So that is how. And also the shoe what you are wearing, that is very, very important. Whether it is a regular shoe or whether it is a sports shoe, you have to wear a proper shoe. That is very important. That is also small things. We think that okay, it doesn't matter, but small things also matter in the life. The shoe what you wear, two things it will use. One is to the side. Yeah, when I was one of my friend, he was having the rubber industry. That rubber industry is who manufactured the chappal and the shoe and all. So I asked him, like there are different. He said there are different types of rubber. A big sheet comes and then they cut it and make the chappals and the shoes. He brought various types of rubber. Then I told why there are less cost, high cost. No, he said no. If you use the less cost, it impacts the eye also. How come? I said, he told me to wear the 3 different type of chappals or the footwear. When I wore it, I felt different. 3 different experiences, 3 different. So he said it impacts because if you see the anatomy of the foot, then you'll come to know. Who are your bio students will know better than me. Second is it also impacts your knee and the ankle. So that is why whenever you buy a shoe or a chappal, whatever you're wearing, please buy a good one. Okay, let it go, maybe 10-15 extra, but buy a good one. Buy a good spectacles also. Why? Because I told you the cold wedges are there. The same, suppose example, a police or a Ray-Ban. Okay, I'm not brand ambassador, but the thing is, here, if you use like the cost of Ray-Ban or police is around 800, starting 800 dirham, something like that. The same piece, exactly the same piece you'll get for 40 and 50 also. Material is same, looks like same, exactly same. But if you look, the lens is grounded at a very microscopic level for police and nanoscopic level. Very, very minute cold wedges are also removed. It becomes very, very smooth. Whereas the first piece is not that so smooth. And it brings, the power of the eye will increase for the first piece. So that is why you need to use a good shoe and a good lens. Okay. And the lenses, what you normally wear, they're already perfect lenses. No need to worry about that. Because they are already, some are made up of plastic and some are made up of glass. Both are available in the market. So they are already well grounded. No need to worry about that. Okay. So now, Clear with you all? Yes. So that is
Sir, I didn't understand the second example.
which example? This one, crockery.
Yes, sir.
Between the crockery item, the glasses, like suppose you have glassware or the plates. Between the two plates, we place the cotton or paper, right? In between the paper fillings between that, or thermocol between the two plates. Did you notice this? Anytime? Yeah.
Not really.
Did you notice this? Suppose crockery or any electronic item, you will have some paper fillings or thermocol in between. So that is because the
So like between the plates.
between the plates, two plates.
Okay.
Yeah, did you notice this? So between the two plates, they keep that because the impact of the plate, suppose when they're vibrating. So what happens if there is nothing between, one will hit each other and they'll break. So the thermocol or something, it will absorb that shocks. One more example, shock absorber is also there. In the car, you might have seen for the cars, luxury cars, we have very good, like BMW or Mercedes, if you take, or Nissan Petrol, if you take, the shock absorber is very, very good. Why? Think that example I will give again. Suppose you have a car, a very good car. You are going from Sharjah to Abu Dhabi. Okay. And, if you are traveling in a Nissan Petrol or Mercedes, 1.5 hour, you don't feel like a ride. Okay? You don't get tired, right? Yeah. If it's a good car, you won't get tired. You will be like, even after reaching there also, you're fresh. Okay, you just, but think that for a moment, think that there is no seat. It's like a bench. Instead of in the place of seat, there is a normal bench. No cushion, nothing. Okay, you want to travel from Sharjah to Abu Dhabi. After 10 kilometers, what will happen? You will get down and you'll sleep in the desert somewhere. Is it not?
Yes.
Yeah. Because all the shocks, your body is absorbing. All the shocks, your body is absorbing and you'll get tired. The same thing happens in India. In India, not all roads, in some village roads and all. Even you travel for 25 kilometers or 30 or 50 kilometers, you get so tired because roads are not good. Vehicles are not good. Old vehicles with no proper absorption of the shocks also. So what happens when you travel for 40, 50 kilometers, you get so tired, you want to take rest. But here it's not like that. The road conditions are very good. So that's a difference. So whenever you buy a car also, you have to take care of all these things. Okay. So these are the examples of impulse. Okay. Now next one is conservation of momentum. Okay. Conservation of momentum. So what is conservation of momentum? Conservation of momentum is like in an isolated system. In an